We now have a panel on elementary school math circles. If anybody would like to join the panel, you can add chairs, or you can have moderators. So I think maybe same pattern of each person introduce themselves, say a couple minutes, and say a couple minutes worth, and then we can go to questions. So, Olga?
Okay, so thank you. We started elementary math circle at Los Angeles Math Circle exactly a year ago in April. We have children grades kindergarten through 4th grade. They're all together, so that certainly presents some challenges. We find different ways to deal with this. The majority is 2nd and 3rd grade, and it's very different experience than running math circles for high school students. That's where I started, and even then middle school. The approaches to deal with them that I found effective are different. The types of problems are different. The attention span is different. So I think I'm on a long journey to learn more about this age group and working with them.
I started these maths classes. We never call it circles. Now I will go back home and call them circles. So math circles with the middle school. But I have a daughter who is now 11 years old. But when she was young, her friends used to come as parents thought that since I'm a maths teacher, I know lots of maths, so they would send her friends, and then I had to do some maths, create a mathematics environment in the home and teach them maths. And what I used was a playway method, which she was talking about, and worked in such a way so that they did not understand that they were doing maths, but actually they were. So I would set up a library, and then I would be one of the managers, my daughter be one of the children being a librarian, stamp dates, future dates, in a way learning about the future date, trying to calculate dates. So 3 days ahead, she had to return the book. So sort of simulating the whole situation, or a vegetable market, and then plan out activities. So this is how I did with the elementary students.
And you already know about me, because I already introduced myself and Julia brought.
I'm Dave. I thought I'd sit up here since I'm running Berkeley Math Circle session for 4 to 8-year-olds, and so I can answer questions.
So do you have any feeling whether these elementary math circle students will continue going from math circle on through high school and into college, or is this just something that they kind of dies out in 5th grade for these group, and a different group comes into the middle school?
My students will continue. Because I have what I was sharing yesterday, that idea, a math circle, which I understood, a math circle for the students, by the students. Suppose a child comes, a group of children come to your math circle. They are here for say, for 6 months or so. She showed me certain activities on weighing machine. They learn, they do practice on them. At the end of 6 months, there's a maths festival where the children put up their own tables, they create the problem, they set up the table, they are handling the table themselves for kids and parents who come and visit the festival. So when a small kid comes to the festival for the first time, he doesn't know he will join a circle, but he comes to that festival, looks into an older kid who's trying to explain him a weighing machine, the working of a machine, and he plays around. So he knows that he would be 6 months after it, he would be he. Like he will be at the back of the table, and that this person who's explaining, he knows that I will be that. Like I know I will be one of you 2 years ahead. So I have a goal in my mind that I have to be one of you. At this stage, I find myself to be like, I don't know much, I'm learning. But I have a specific goal. I've seen Dave, I've seen her, I know what I have to be. So once I know what I have to be, from there I know I will continue it. I know exactly what I have to do. So for a child, if the level goes on in this way. So if that little one knows, that elementary child knows that yes, the middle school people are doing this, so I will also set up a table. The middle school child knows that the senior school is doing this, which is a lot more interesting. So the circle continues. I feel it's, then the circle comes to, so it goes in a spiral. This is what I feel.
So I wanted to also comment on this. I think it's much more likely that if children start earlier, they will continue. That's what I found. So I now have approximately 100 children between K and 12th grade who come every week. And the statistics is like this, that for example in the high school group I have very few girls. So my observation is that unless they start middle school or earlier, they're not even going to come. In the middle school, I'm sorry, the majority is girls, and they're doing so well. And in elementary school, it's roughly half and half. I don't know how it happened. Also, what's happening is that I see a couple of children in the elementary school group who are so much ahead, and I suggested to move them up. I told them it's going to be a big challenge. You're moving from a 1-hour session where you have an instructor with you in a very small group to being more independent to a 2-hour session. Try it for 1 week, just a visit. I didn't even tell them that I'm transferring you. You have a special visit day, and then you tell me what you want to do. They all said, I want this challenge, and they told other friends. So other friends want to go up as well. So now I'm faced with a problem. On the high school level, and this is eventually, I'm hoping to build a continuous program from elementary up to high school. I have students who graduated from Math Circle last year. One of them is at Oxford University right now, the other one is at Stanford. The two of them come this year back and give their own sessions. One of them happened yesterday, one is 3 weeks down the road. So I think seeing each other, and they will teach to the kids with whom they were together last year. So they already know that this Emmanuel, who was a student next to me, is going to teach next time. So I think there are mechanisms to keep them interested.
Well, I don't know, of course. What I see, that I have two helpers, again, relating to what Ratuli said. They love when the older kids teach them. So they see them as role models. So they do understand that they also can be at this place, teaching interesting things to the kids. So some of them already asked me whether, when they're in the middle school, whether they will be allowed to teach the elementary school. So another thing is they formed very strong friendship. So it's a very tight group right now. They play together outside of the class. They have play dates. They not only do mathematics, but they play chess. They do gymnastics together, whatnot. So I think that social part of it will also keep them together and wanting to continue. So, but again, of course, I don't know, because we also have magnet schools in our area. So the kids who are in the 5th grade, their parents may choose to send them to magnet schools. Magnet schools are very far away. So it's a very long commute, and the kids come very tired. So I don't know yet. I haven't been in this situation yet. All the kids are still small.
We don't have statistics at Berkeley since this is the first year that we've been doing it. Some kids will come back, some won't. We know that just from the one semester. I can comment that we are having the same phenomena that Olga says. We had an 8-year-old who started out in the elementary circle and is now in the high school circle trying to answer every question like this. We also have been having an age thing where there were the siblings looking in the door. So it started out with the 6-year-old was the youngest we were going to accept. Then we went down to kindergarten, and there was this 4-year-old sister who just would not quit doing the activities, and we could not keep her out of the room. And so now we have this 4-year-old in there doing things.
The groups are self-selecting. Has anyone ever tried to run a math circle that wasn't? Would you take 10 kids at random? What would happen?
I've done that actually. We go into boys and girls clubs and just dump polygons or something on the table, and they're still self-selecting, but we'll get almost all the kids to come by and try to examine phase vectors or find all the platonic solids, give them the definition or that kind of thing.
So not everyone engages, but you probably have more people doing it and learning it than you would otherwise.
Well, we have, when we go to the Boys and Girls Club, I think there are, 100 kids of elementary age altogether, and we have 75 of them come by 1 week or another. Some come every week, the whole time, for 2 hours at a stretch, and some drift by in between playing in the gym and doing art and playing computers.
What you just said about having kids move up, this one seems to contradict very much what was the first big thing which I read in the Circle in the Box book, which said you always start as a high school circle and after a while it degenerates and becomes a middle school circle. Can you comment on that?
Well, since I'm doing it the other way, I don't know,
I think that's exactly the reason. Because let's imagine you start a circle at level X, and then younger kids start looking at it and saying, I want to get in, I want to get in. And so if we just had the high school circle.
The way I read it was that the high school kids then drop out when all the young ones come in. And it said, I read it as a warning, be really, really careful, don't let the little ones in, otherwise you won't have a high school circle anymore. Did I misunderstand that?
I think they meant that high schools graduate, no?
I think you mean that you can scare some.
So I was at the circle that Sam is talking about there. So the dynamic was that we started with a high school circle. There are a lot of really talented high school kids in the area, so it was a really high level. And the younger kids kept wanting to come, and as the instructor looks at this room that now has, so many faces that are middle school kids, first of all, there's not going to be much trigonometry used anymore in this circle, that kind of issue, for one thing. And also, you just don't want half your audience to be lost as you're zooming at the speed of the top kids. So after a little while, the top kids stop coming, and now you have only the not-so-sharp high school kids coming to your circle. And then they start to realize that they're actually in the minority, so there's all these much smarter than them 6th graders, right? And so I don't want to sit here and be the stupid 11th grader who's being outshone by all these little kids, and so then they stop coming, and now you have a middle school circle. And so Sam's solution to this problem was just, you should have parallel sessions. So when the younger kids come, the super sharp ones maybe can go sit in with the high school students, and you can just continue teaching at the high school level, but the middle school kids who want to come, you need to start their own class. And I think that's ultimately going to be the solution in Berkeley, too, is that if a lot of 4- and 5-year-olds are coming, ultimately there's going to be a separate class for 4- and 5-year-olds so that the 6- to 8-year-olds can have a class that's at a good level for them.
But that doesn't address the question about, because I've seen this in a different setting, of the 11th grader who just cannot bear to have an 8th grader do better than you.
Yeah,
That doesn't address that.
This is a very difficult phenomenon, and I would say that it peaks around maybe 8th, 9th grade. There is no way that you can put an 8th grader together with a 6th grader, and especially if they see that 6th or 5th grader is much smarter and faster. I don't have this problem in elementary circle. That's the thing that we're supposed to talk about. For some reason, 4th graders, they're totally okay if they're together with kindergartners, 1st graders. 11th, 12th graders, they're fine. They know that they're supposed to be the older. So whatever these younger kids are around, that's fine. But 8, 9 grades, they so much want already to be in high school, even if they didn't take algebra yet. They already want to be together with high schoolers. So I had a lot of people quitting because of that, and then you just have to explain to their parents that you have to be tough, and you have to accept that there is a younger person in the room who is much smarter than you are. I accept it every day because I have very bright 6-year-olds in the room. I'm not as bright as them. Well, that's fine. So, but I don't know a perfect solution to deal with this, unless you separate them. But then,
A perfect solution will be something like this, where everyone is interacting, the young, the seniors, the juniors, everyone interacting for this. Like if a teacher can make mistake, the one you said make silly mistakes. So teachers also don't know. So seniors also may not know, juniors know.
I think for those things we have to think a little bit and try to set up parallels. For example, we have a graduate class where we have tons of undergraduates coming in, and how does that change the level of the class, and then the class actually becomes a different class. In my case, when I was coaching soccer, we had some very bright, very good kids in there. We were going for a tournament out of town, and the kids want to watch a movie. Wrong age. One of them can't go in because it's too young. And so there are tons of those conflicts in there. And I think sometimes we should not look exactly at what we are doing with the middle school and high school session, but I say, how are we handling something like a situation which is similar? How do we handle it in different places? And do we have solutions? Do we not have solutions? Maybe we can transfer some of those. And it's about how we think.
Let me just comment. This comes from the summer enrichment program, the science program that ran at the University of Puget Sound, a 4-week program. And one of the things you want to pay careful attention to is not necessarily the academic side of things, but the social side of things. At a certain age, you'll find out that into the sort of middle school or high school things, the older kids don't want to deal with the younger kids. It has nothing to do with being shown up or not being shown up. It just has to do these kids are acting like they don't want to deal with their parents. There's an age when people reach they don't want to interact with people who are sufficiently different. And you want to pay attention to that. That doesn't mean you can't mix. We decided we could mix two brackets. We could put the 11th and 12th graders together, we could put the 9th and the 10th graders together, but it got to be a real stretch if you ever tried to put 3 grades together. There was a lot of, what would tend to happen is the youngest in the groups would sort of form a subgroup in that group, and the oldest would also form a subgroup. Whoever was, the middle ones might go either way, but they would be very little interaction, and it's a social issue. So just pay attention to it. I mean, that doesn't mean you can't work around it, but be aware of it.
Okay, so my 2 cents. So again, there is a very important aspect. A mathematical circle is supposed to have social aspect of getting kids who think the same way together. And it's, well, at least for our circle, it's very, the social aspect is very important. We are trying to make them friends. So we had situations when, so we try to keep kids in a single circle, not more than 3 years apart. So we really had a situation when our 7th, 8th grade circle, some 12th or 11th grader wants to join in. He's definitely capable to do it. But we turn them in because, sorry, it's not your, the balance of the circle would be shifted, right? You are too many years apart. So in our case, we apologize, but we say, you're not fitting age-wise. And now in my 6th grade circle, like some bright 3rd grader is interested in joining in. And I am going to let him in, but I have a big concern because it's going to be disbalanced age-wise. It will be hard for them to communicate and to work together. And it's important to build a community for these kids because they kind of, sometimes they're lonely in schools and they look at these circles as a social interaction thing. That's one of the reasons why they like it. And it's a job of the teacher to kind of, to create the social interaction, to provide it.
I would go even further in that direction. One of the goals of what we're doing, we haven't talked much about this, in Math Circle is create a social situation for these kids. It's very important, bright kids are frequently isolated. Kids who are nerds don't want to be nerds. Being a nerd is a defense against the social problem of being smarter than other kids. So I would say that's equal to our intellectual goal, is finding that, and they support each other. And then we go out a little further on a limb. There are a number of Russians in the room, people from Eastern Europe. A lot of what happened in Eastern Europe is that people's intellectual life became their social life. They were the same thing. People lived and breathed mathematics because that was their friends. And this was the beginning of it. And there are all kinds of other reasons for that to happen, which maybe we won't duplicate here in America, but it's just an important part of what we're doing, is bringing these kids together.
transition plan if you're gonna hands off or something like that.
But
Did my question make sense?
Yes.
by who's the you?
Well, let's say that you're leading a circle because you're a parent. You have a big motivation to run the circle. But then when your kid is in high school or in college, then why would you continue?
I don't know. I said it in my presentation. I don't know.
So you're doing some wonderful things, but after your kids graduate, then
Correct. There is no other interest right now in the community in what I'm doing, other than those people who are bringing me kids. I have a long waiting list. I have a real job, 3 kids. I'm homeschooling one of those. My oldest kid is a special needs child, so I can handle only so much.
Well, you're generating artifacts that make it easier for those who follow.
And I'm trying to write a textbook, something with the lesson plans that I'm using, of those that I'm doing right now. So other people who may decide to do something similar will start not from ground zero, but from something, that is sufficient to run, for example, a math circle for the first year.
Let me comment to this first in a couple ways. One is how do you keep the circle coherent and keep it running? The fact that you've got the brothers and sisters and friends is a big help. In the Berkeley Elementary, it started with Natalia and Ilya because they had stoma. Stopa. They're 7-year-old. John is 6. And so she left, and she was working with Laura Giventhal, and now their kids are moving up, so they're moving up. And so then I moved in, Lena moved in, Sergey moved in. And we're getting 2 different things here. Lena's kids went through, she worked, and now she's sort of rotating back to the beginning just because it's fun to start with the younger kids again. And then Natalia's going to a different location, but she's collaborating with the kids, and she knows that there's other parents in the math department who have kids who are younger that she's going to bring in to sort of follow up as she moves up the ladder. Is one natural way to make things a little bit continuous.
Yeah, I was going to say it's sort of exactly the same idea. The trouble is a lot of these circles seem to be run by one person, and when that one person is gone, that's the end. And so it would be great if you could get 2 or 3 parents, interested parents doing it with kids offset, and then when one bails at one end, you try and bring in somebody at the bottom so you get some continuity that way. That might be one way to handle it.
Unfortunately.
What?
No, very few parents want to do it, and very few parents
Well,
have time.
a lot of parents want to have their kids in a circle run by somebody else, right?
Berkeley in every city in the United States. You have Berkeley, and then you have the rest of the world. Boston and the rest of the world.
I think Lynn had.
My sister-in-law used to do this in physics a long time ago, and in the Greater Albany area. But what she did was that she became so popular that parents in other schools wanted their children to do it, but it was too far away. So she had a way of training parents. They would join her in the circle for a little bit, and she would visit them while they started their circle. And she didn't stick with them very long, but just long enough to visit them a couple of times to help them launch in another school. Now, nobody had time, but they had children in another school at the same time, and they knew the circle for physics could only be so big.
Well, then you also should have materials because parents cannot draw from nowhere.
Yeah, and she didn't have anything. I mean, my sister-in-law invented it all and shared it with everybody. But now it's a different time because you have MSRI and you have this. It seems like it could be a different time.
We're trying to make it a different time. That's exactly the point of these workshops, is to collect all the materials together, make a community. How do soccer clubs work, as Matthias says, right? We're having plenty of soccer coaches and parents. We want to make plenty of math coaches and plenty of people moving into the system, being trained, having. So that's what you're on the ground floor of creating.
Well, there's philosophically the issue too. Are we AYSO soccer or are we club soccer?
Now we have finances once here. I always thought that football was played on the streets, and that's the poor man's ball. He had costed $2,000 or $3,000 a year.
That's right.
And it's the same way as a piano teacher. And I still do not understand how we can make math circles sustainable at the price. I mean, what should it really cost to be a member of a math circle? When the funding runs out.
I think Shira.
I had a very different couple of questions, just very procedural. One thing we've been having with our math circle, so we want to keep it informal, we want to foster this social environment, but if we don't have students raise their hands, you have the two kids who will just shout out answers. One kid shouts out answers that are correct, one just likes goofy questions and jokes and will shout those out. And we want to keep it fun, we don't want to make it like school, but we want to make sure everybody has a chance to think. So that procedural question, and also how do you get them to come on time?
I can try. So what is the age that your first question I think is very age related?
4th and 5th, and
Fourth
about
and
half
fifth
the
grade.
parents don't speak English.
Say it again?
4th and 5th grade,
Uh-huh.
and about half the parents don't speak English and don't have cell phones. So communication with the parents is an issue, and don't have email.
Well, for communications with parents, it's not important to communicate on a daily basis, but one thing you can certainly do, and that I've done in the past very successfully, you can have a very informal parents meeting. You can explain to them what you are doing, they're going to hear it out, and it's very good for you to hear what their point of view is. And so maybe you can find some common ground. So I have parents meeting maybe twice a year or at least once a year. This year I already had it twice, so for different groups, but and certainly to ask them to come on time is a possibility. Another very simple mechanism, you cannot always regulate it just because parents come from very long distances and face traffic. We have a warm-up problem, which is independent of the lesson very often, and when kids are working on this, late arrivals arrive late, right? That's what they do. As to as to shouting out the answers, I think this has to be handled on an individual basis. And again, it depends on the age. For 4th or 5th graders, sometimes just smile and make a joke. Someone other than Ellen, I don't know. It depends on the kid, but.
I think I found when I tried that, somebody other than Jeremy.
Yeah.
Some of the other kids, I think now, are so used to him being the one to take the lead that they may not even attempt to solve the problem themselves. So once we've eliminated him from the picture, they haven't even tried, and they all.
But so this is because you present the problem most likely orally or on the board. If you give them handouts so that each of them has to look at something separate, this handles this automatically.
Or different handouts maybe.
Yeah, that's definitely.
Or maybe 2 different handouts of similar question, but the numbers can be changed. Like the same question with different numbers.
Yes.
So 3 sets with 3 different. So even if he shouts the answer, it's not the same for the other one.
So have you tried taking Jeremy, I guess, aside and explaining to him, or trying to redefine his role as instead of a peer, as actually a helper or a leader? So trying to make him sort of into almost a second tutor or leader of the circle. That's an old math camp trick.
That's something that we thought of yesterday. It came up in one of the presentations. We thought making him, or having him lead a session. So I think that is something we're going to try.
I think sometimes, too, you can ask him to see if he can solve it another way. However it was you approach the problem, is there a different way? And encourage the star goes to the one who can come up with the most different ways of approaching.
We do sometimes make them work in teams, like 2 teams, and each member of a team should present a solution. So, and if they go not in their turn, the team is losing a point.
In my circle, sometimes I ask them to raise their hand, like, who know the question, who know the answer, raise the hand. And I do have 2 very bright kids, their hand
say that we are waiting for more hands. So if that is why they don't shout out the answers. Others don't know the answer, and they don't know, wouldn't proceed till like somebody else raise a hand.
This is a classroom management question. And there's, in your city, there's thousands of math teachers who face this every day. And some are extremely skilled in this and some are terrible. But if you can network with teachers and find, like ask who's a good classroom manager and actually go visit and see a couple of these classrooms, you'll learn a lot by seeing someone who actually does it well than just hearing tips.
Perhaps Brandy?
Well, and I think building off of that, just using different ways of getting answers from students, because then not only are you going to take care of that, but you're also going to hear from students that would normally respond. So maybe everyone has to write down their answers, and then you read one of the answers out loud. Maybe you write down 5 names, and the person that's fifth is the one that goes first, and then you read backwards. So that person that puts his hand up first is going to be the last one to respond. You know, things like that, so you're hearing from different people. In terms of snacks, at least at my circle, the idea originally was that they got put out 15 minutes before the program started, and then they get put away when the program starts. So kids are going to tell their parents that they got to be here 15 minutes before, because they got to have that snack. The kids are going to make sure that they get it.
That's a great idea.
I think some actually had a question before, after Shira.
No, I was just curious whether family math used to be popular in the Berkeley area. I was wondering whether that reached into this, whether these mixed in any way. It was.
I haven't seen it. Perhaps some of you were Berkeley.
The family math.
Family math was a movement 15, 20 years ago, and my child got older, so I haven't followed it since, and I was trying to do the same thing that circles are to some extent, and I'm just wondering whether it disappeared, or whether it's independent, or whether there's any melding.
Nancy still uses some of those materials, I know, but I don't know about the circle before.
Yeah, that's
That was it was also equals in the Lawrence Hall of Science. That was that group, right?
yeah, a lot of them were at Lawrence.
But I don't think that they were math proficient.
Some of them actually, some of them were.
Where are they?
I'm looking for
Santa Clara was one, Berkeley was another.
It seems that equals is still there. No website. The last time they posted all the materials in Spanish.
Published, I just sounded like math.
David?
I'm going to stand up and demonstrate. This is one thing that a educational consultant that I know has suggested. I've never really used it, but for asking people to, if they have the answer to the question, they're supposed to get hands on their chest and they can raise their thumb rather than an arm. The point is that the other students can't see who's got it. Or if you have 2 answers, 2 ways of doing the problem, you put 2 fingers out. 3 ways, you put 3 fingers out. The person leading can look and see who has what, but the other people can't, in the class, can't see who's got what, unless they, and if you're in a real circle, this is a little different. If they're in a classroom type setting, you can do that to hide who's got the answer. And you can just ask them to do it that way. This may or may not work, depending on what
I think Max before we.
Do you all ever notice the students complaining that the public schools don't do things like you do in the circles? And does it influence how they view the public schools?
They don't do anything that they do in school, so there is no connection.
Doing the way you approach math, being more interactive, and the school is not like that.
My daughter complained to me, so she said that it was boring in class because she already knew everything, but this is a different issue.
I've certainly had indications, at least from parents, but then let's face it, they still have to go to school. And for their own good, it's best if they learn to accept it, or at least, kind of make environments with some degree of success. Of course, you can solve this problem the other way. You can start homeschooling.
Now you have
some of the deal, but
two people here who are homeschooling.
right.
So
But I don't advocate homeschooling, at least not to my math circle parents. So what I'm trying to point out to the kids and to the parents from the beginning, we're different from schools, we're doing different things. I respect schools, there are excellent teachers there, and just we're doing different things, and that's it. They don't have to look the same way. They're still going to go to school. Why would I, They can see for themselves what the difference is, but
I've done groups just to experiment to find what works of 5 to 7 children of the same class. It started with the top students, and I've noticed, they hate the regular class. They'll run in when I come in. I started with the top students, and the other kids, there's a lot of bad stuff. The other kids thought that they were stupid because they weren't in the group. Then they thought that they wanted to go to the group because they were missing out on something. So I took everyone at different times and shuffled them. So now when I go into the class, they line up and run to be the one to go. And they don't like sitting in the regular class. It's not as much fun.
Lynn, I think Lynn actually.
Well, I was just going to say, since we were going back to old projects, there's something called Project Seed. It was where I started working. And their website is still pretty good, and they talk about the methodology, and they have things for example, if Jeremy calls for Jeremy, you get to call on somebody else. It's the same sort of thing that they're saying over here. So there are websites that talk about this sort of enjoyable classroom management.
I will make one comment about these other programs that are happening. Of course, we should network and interact and collaborate with them. So if you know of other programs, other past programs, please send email to me or to Josh. Josh is the director, and let's get links on it so that all the material's out there for people to use and see and comment and discuss.
May I invite questions? The thing is that I think, at least in informal discussions, many people ask, what can you do in terms of mathematics with elementary school children? And I think there are a lot of things to do. So if anyone has questions about mathematical aspects of elementary school circles.
You want to say something about that?
I think there is a question.
Well, it's not a question about the content, but have you written something up about what you do if you get onto the website?
It is on the website.
It is on the website.
It is already.
All of the BMC materials are on the
Okay.
website. And we'll link those all to the NA and
Okay.
I want to go back to what Max was saying about, other people saying about graduate school and math circles. I feel a little defensive as a teacher. I did math circles in a small community, and I was looked upon askance by other teachers. What is he doing as a teacher? At one point, they thought maybe these kids are going to skip 6th grade because the 6th grade teacher was not supposed to be a good one. And, all kinds of rumors started flying. So, for whatever grade. The first thing I did to handle was make sure people knew that I didn't do things. I eschewed things that they were going to learn anyway in math. And then the other thing, so that helps a little bit. And then the other thing is that this is sort of an infantile disorder in the sense that pedagogy is changing, even pedagogy in schools. And as a teacher, I changed my pedagogy from normal class that I was paid for on the basis of what I did in math circles. I often use that as a playground for people that I would then do with the kids. And by the way, a lot of times things that I do with elementary kids are applicable to high school kids in different ways. So I think that it's important that especially like in teacher circles, we influence the pedagogy. If it comes like that.
I'll take Shira as the last question because I saw hers before. Shira?
Julia said in her presentation she didn't think her kids were ready for proofs. And it was best to just sort of introduce the concept with some fake proofs and then leave it at that. How do you feel, at what age should that start?
Well, I don't know yet. We will try every year until I see that it's working.
So greater than or equal to what?
Huh?
Greater than or equal to what? You have a lower bound.
I have the 9-year-olds right now. So maybe next year they will be ready. I don't know. We probably need to start ask Olga.
I don't know, if you can give them an example where the proof is one line and it's a very obvious argument, then you can do it. You can do pigeonhole problems with elementary school children, and it works. You can take the problems where you need, take several balls out of a hat and then replace it. But pigeonhole problems, something that we've done last year in May with first, second, third grade, very successfully. They got it.
Maybe some parity. Parity should be.
Parity, definitely, parity was our first topic.
So-
So indeed, ask them, I don't know, prove to me, eventually they should, I make them actually formulate the statement themselves, but eventually they come to the fact that they need to prove that an even plus an odd is an odd. And they give you, it's a proof, can't argue with that. They come up with this. They build models, they find ways to think about it.
So at this point, I think I will actually make the panel discussion continue, but as we walk towards university and college and do lunch,